In this video, we're going to go over a more complicated area between the curves problem, and it's going to be one where I'm going to use the Inspire to do a lot of the work for us. And really, it's going to be a nice survey of a lot of the tools that the Inspire brings to the table. So it'll be a nice way for you to kind of see all the power that the TI Inspire has when it comes to graphing calculus problems. All right, so let's head over to the Inspire right now. All right, so the first thing that I did is I opened up a graphing table and I entered the function here. Remember that if you want to put in quotients like this and have them look pretty, you can just press Control and then divide, and it gives you that numerator and denominator there. And so once that's in there, we're going to press return, and here is our function. And if this function does not look like the one on the graph paper, take a quick look and see if you can figure out why that would be. Da, 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 da. This function is completely correct. The difference is that I'm in degrees when all calculus is done in radians. So when I click that to radians, it looks a lot more like it does on the sheet. Good job. All right, so the first problem that they want us to do is to find the area of region R, which is this area here between the curve and the x-axis and the y-axis here in the second quadrant. So that's not a tricky problem, but the one thing we need to do is we need to find the coordinates here. It's somewhere between -1 and -2, but I don't know where. So what I'm going to do is I'm going to go to Menu, I'm going to Analyze Graph, and I'm going to find the zeros. This is something you did back in Algebra 1, I remember. And so what we're going to do is we're going to select a lower bound and an upper bound that contains this, and it's going to find those coordinates for us. All right, so we know that that point is at -1.37. Intersection point is at -1.37. So we want to find the definite integral from -1.37 to 0 of just f of x dx. And so doing that, we're going to analyze graph again, and we're going to find an integral. And they want us to choose the lower bound and the upper bound. And so now that we've got that point, we want to make sure we select where it says intersection point, and the other one is going to be at 0, and it'll lock in there. It's the intersection point of the x-axis and the y-axis. So when we put that in there, the area that we get is this 2.9 right here. All right, it's not a lot of precision, but it'll be good enough for the work we need to do. I'm going to pull this off to the side just so it doesn't trouble us for the rest of this problem. All right, so now what they told us earlier in the problem is that there is a line L which is tangent to this curve here at the point 0, 3. And so we want to find the equation of that line. All right, so what do we need to do to find the equation of a line? What two pieces of information do we need to know? Well, we could put it in slope-intercept form if we know the slope and the y-intercept. We do know the y-intercept. The y-intercept is just 3 because it goes through this point 0, 3. But how can we find what the slope of that line is going to be? Well, the line is going to be tangent to this curve at 3. So it's going to have the slope that is the derivative of this function at that point. All right, so how do I find the derivative of a function? Well, I'm going to click Menu again. I'm going to Analyze Graph. This time I'm going to find dy dx. And they want to know the position. And so the position is going to be right here at this intersection point. And so the number that came up is this -0.5. And so that was the derivative for us. So let's take a quick look. Let me take a detour back over to my document camera, where I've been keeping track of the work at this point. So the slope of the line L is negative 0.5, and the y-intercept is 3. So the equation of line L is y is equal to mx plus b, negative 0.5 x plus 3. All right. Now, let me take a break from this and go back to the calculator. All right. So now I'm going to enter that line. So I'm going to press Tab to enter a new function, and it's going to be negative 0.5x plus 3. All right. So that does, in fact, look like it's tangent here. And once again, I'll drag this off to the side. All right. And so now they want to know in part 3 of the question, at what ordered pair other than 0, 3 does the graph of line L intersect the graph of line f of x? So they're talking about this point over here. All right. So to find that, once again, this is something we used the Inspire for back in Algebra 1. We're going to analyze graph again. And this time we're going to find an intersection point. And once again, I just want to spread this curve over, or spread that region over where that intersection point is. And that gives me the coordinates of the points, which is 3.39, 1.31. All right. And so the last question that they have is to find the area of region S. All right. And so we can do that. Let me go back to the document camera for just a second to show you how we would write this if we were writing it by hand. All right, so the area of region S, so once again, we want to find the difference between the curve that's at the top and the curve that's at the bottom. So this is going to be the definite integral. The curve at the top is negative 0.5x plus 3 minus the equation of the lower thing, which is this whole monstrosity. All right, so that's x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine of x dx. All right, so that's awesome, except that we need to know the bounds of integration here. So what do you think the bounds of integration are for this problem? They're numbers that we have looked at previously in this problem. Well, we're looking at this intersection point and this intersection point. And so we're just looking at the x values. So the x value of that point is 0. And the x value of this point is what we calculated right here, which is 3.39. Okay, so we could calculate all of that. We're not going to do that by hand, but we could put that into a graphing calculator to work for us. But I will show you that there is yet another shortcut we can use here. We can find the menu. Once again, we're going to analyze graph. And what we're going to see here is bounded area. And you kind of see that they've got two curves listed there. And so once again, they're going to want us to pick the lower bound and the upper bound. And so there's our lower bound. And there's our upper bound. And so the number that popped up for that is equal to 6.98. All right, so that was an awful lot of work. You needed to have done that much work, well, pretty much, to have solved these two questions using the calculator. It wasn't just for the sake of filling out this worksheet. You needed to have known the equation of that line so that you could put it in so that you could calculate the difference between the two curves. And you would have needed to find the other intersection point so that you had those bounds to calculate the difference in the areas. So I hope you kind of enjoyed seeing all of the functionality that you can use, at least from the graphing calculator side of the Inspire, to solve a problem that looks like this.